So let's talk about confidence intervals. And before we do, we're going to need to take apart the words. First of all, we'll look at what an interval estimate is, and then we'll talk about what the confidence means. So we're going back to our cereal bowl example from Chapter 9, Do You Drink the Milk? And if you haven't seen that video, please watch that, and this will make more sense. But now, in this case, we are going to take away the magic information. I don't know if you remember, but in that case, and I'll just write them over here, we do not know the percentage of people who drink the milk. We're curious about it for some reason. Maybe we've invented a project. We've invented a product that involves, a cereal bowl that keeps the milk in and is easier to drink or something. I don't know. We do not know the population standard deviation. All we have is an idea and a survey. So we are going to conduct a survey, and as we choose our sample size, we should probably talk to more than 4 people, maybe 100. I don't know, let's make it 400 people. So these are the numbers we have. We don't have these magic numbers over here, but we do know that we can go out and conduct a survey, and our class would be conducting more surveys at this part of the school year if things were normal. We're going to ask 400 people, and we're going to find out, I don't know, let's just say I got 248 people who said, yeah, sure enough, last time I had, of course we phrased the question properly because we're good students of statistics. Let's see, actually we want to say X. So our number of successes, we were looking for a certain number of people who say they drank the milk, and we're going to get 248. 248. Okay, and these are the numbers that we can realistically get. I don't know why sometimes my blackboard's not working here, but that's a 2. You have control over the sample size, and once you do your research, you have X. And now if you do just a little bit of math, you can get, so from these numbers, and I don't know, just for fun I'll put it in a different color. These numbers will then give you a sample proportion. We're interested. Is it more than 50%? And if we just do this math, 248 divided by 400 is going to give us a 62%, and that is our sample statistic. Okay, what does that mean? Well, we got these 400 people together, and now we have a number that describes something about them. 62% of them drink the milk after they're done with the cereal. And then another statistic that we can come up with, and it's not sigma here, so I'm just going to draw that and cross it out, but S. S is our sampling standard deviation. And when I say sampling, I mean our sample. We took one sample here, not over and over and over, just one sample of 400. We got one number, 248. And from the N and the X up here in white, we can calculate sample standard deviation. And that is taking the I guess I'll write out the formula for it. It's the p hat times q hat divided by, since this is a sampling situation, we're dividing by the square root of n. And here we're dividing by, I'm supposed to write that as n, sorry. Okay, so you plug these numbers in, you get 62%, that's a 62, times its complement. What would Q be here? It would be 38%. And we're multiplying those, and we're dividing by 400. That gives you a tiny decimal. Strange thing about tiny decimals, when you take the square root of them, they get bigger. And my calculator told me that this was 0.0243. So what have we done? We've done a survey, and we had control over these two numbers, n and x. That gives us two statistics, a sampling, I'm sorry, I keep calling it sampling, a sample proportion and a sample standard deviation. Okay, those all came from our research. And if you were going to report on this, you could say that the, according to our research, 62% of people drink the milk. And our study had a standard deviation, I won't even use a symbol, I'll just use SD, abbreviation, was 2.43%. Just changing to 2.4%. Okay, and that's, that is a research result, but that's not how statisticians and researchers report their results. And I'm going to stop this and start a part 2.